Hello everyone. This is just the recap of all four equations of Maxwell. In my previous videos, I went in details through each of Maxwell's equation. In this video, just I'm recapping. So Maxwell didn't just collect four unrelated laws. He showed they are part of a single unified theory of electromagnetism. Each of these four equations describe how electric and magnetic field relate to each other and to charges and currents. The first law, Gauss's law, uh, electric charges are source of electric field. Charges inside a closed surface. That's why we have here is a little circle, closed surface, causes electric field lines to emerge or converge. Or basically, it says the electric field is directly proportional to the charge, the net charge of the closed surface. The second law, the magnetic field, Gauss's law for magnetism. Magnetic field lines have no sources or sinks. They always form closed loop, so there is no magnetic monopole exists. So that's why the result is zero, because we cannot split the north and south pole of the magnet. So they come together. The third law, Maxwell's third law, the Faraday's law, it says basically a changing the magnetic field creates or induces an electric field that forms in a closed loop. So always know that it's always closed loop. The first and second equation, it's in the closed surface, and third and fourth equation, it's in the closed loop, the wire. So on the fourth equation, the Ampere-Maxwell law, a current or a changing in electric field creates a magnetic field that forms a closed loop. So changing in the third equation, actually changing the magnetic field can induce the electric field, and the fourth equation, changing an electric field can create a magnetic field in a closed loop. So these two, the third and fourth equations, are very, very related to each other. So the last two equations, the electric and magnetic field can create each other, but only if they change in time, that when they're not in a constant but they keep changing. So suppose there are no charges and no wires. Imagine you're somehow wiggling an electric field so it starts changing in time. That changing electric field creates a magnetic field, but the magnetic field is also changing. So we have an electric field. The changing electric field creates the magnetic field, a changing magnetic field, and then changing magnetic field, again it creates the electric field. Since that's also changing, it creates magnetic field. So it basically says it's a self-sustaining wave of electric and magnetic fields traveling through the space. So that's an electromagnetic wave. And Maxwell put all four equations together in empty space and derived the wave equation. And the final equation was like that. So this is the final equation that it come up with, the wave equation. So he calculated the value of C from known constant of electricity and magnetism. So it matched the known speed of light. Imagine you have a capacitor with a plates in space and you're changing it. The changing electric field between the plates doesn't just sit there. It spreads out into the space around it. According to Ampere-Maxwell Law, a changing electric field produces a magnetic field that loops around it. Now that the new magnetic field also changes over time, according to Faraday's law, this changing magnetic field produces a new electric field that loops around the magnetic field. So the electric field generated to magnetic field, the magnetic field generates the electric field, and this process keeps going. Even after the capacitor stops changing, this disturbance of electric and magnetic field moves away into space. The electric and magnetic fields sustain each other by this back and forth induction. So this self-sustaining process is an electromagnetic wave, It needs no wire, no charge, no medium, just fields in space.